Assalamu alaikum students. In today's lecture you will learn about bond enthalpy or bond energy. It includes the introduction of bond enthalpy. Then ionic character and its relationship with bond energy will be discussed, including the factors on which they depend upon, that is electronegativity, size of the bonded atoms, bond length, bond order, bond energy and bond polarity. Today's lecture is related to bond energy or the bond enthalpy. Now, what does it mean? Look at the diagram. Two bonded atoms are present here. To make a bond between the two atoms, there is a rule that the two atoms which have to bond together, they must lose their potential in such a way that the attractive force between them that becomes dominant over the repulsive force present between the two similar nuclei due to the same charge, as well as the similar electrons due to the same charge, right? So they will come to such a distance that the dominance of the attractive force occurs and a bond formation takes place. In doing so, they have lost their potentials. Some of their potentials, they are coming out in the form of energy. So we say energy will be given out. So, or you can also say that thermodynamically bond formation is favored when the attractive forces, they dominate over the repulsive forces, right? Now students, look at this equation. Here the hydrogen reacts with chlorine to produce hydrogen chloride. Here you can see hydrogen is present naturally in the form of H2, means two hydrogen atoms, they are linked together by a single bond. Chlorine is also present in the form of molecule. It is a homotype of molecule in which chlorine to chlorine single bond is present. How will they react? For the reaction, bond between these two should break so that atoms will be released and these atoms will react further to produce the product. Now you can see the hydrogen and chlorine are reacting together to produce this product. Two same units are generated in it. So we say two types of energies are there. One, when the bond breakage occurred, the amount of energy is absorbed to break this bond, right? So it is the amount of energy which will be absorbed by hydrogen molecule or the amount of energy that will be absorbed by the chlorine molecule to break the bond. So this is called bond energy. That is energy absorbed by the molecule to break the bond between its components, between its atoms. And when 1 mole of the atoms molecules are considered, and it is going to give rise 1 mole of the atoms, it is called energy of atomization. It becomes a standard, right? Now here we have the one type of energy, that bond breakage will use energy in the form of heat, that we will heat the substance and energy will be absorbed to break the bond. Now the second one is, look at the HCl molecule. The new bond is formed between hydrogen and chlorine. So what is going to happen in it? H and Cl, they are decreasing their potential. In decreasing their potential, they are releasing the amount of energy to come to a distance that they can form a bond due to the dominance of the attractive force. So we say energy is released in this process when bond formation occurred, right? So two types of processes are there in which energy is absorbed or released. When we say bond is broken, energy will be absorbed. Bond formation will release the amount of energy, right? So bond breakage is an endothermic process, while bond formation is an exothermic process. I hope you understand. Endothermic means energy will be absorbed thermodynamically, right? And exothermic means energy will be given out. How we can get it that energy is given out? You can see burning of fuel. It is releasing amount of energy, tremendous heat, which we use for the different purposes. You are going to cook the food or you're going to heat, the phenomena of evaporation, boiling point, melting point is going on due to all this happenings, right? While if you have to separate the hydrogen molecules or the water molecules, then what you have to do, you will give it some energy so that the bond will break. Remember it. If I have to make the bond and if I have to break the bond, same type, that is hydrogen molecule I have to make, hydrogen molecule I have to break, same amount of energy will be absorbed and will be given out during the process of breakage and then formation. Okay, means hydrogen to hydrogen bond formation, the amount of energy released in this process, the same amount of energy will be absorbed when the bond will be formed between the two hydrogen atoms. Do you understand? Now come to the next one. Here we have once again the bond breaking process, that is termed as endothermic process. That is, if you are going to separate carbon hydrogen bonds in methane, suppose, energy will be required to break the bonds. So it is the bond energy. It is the energy which is required to separate the two atoms in that molecule. Maybe more than two atoms are present in a molecule, just like in water you can have three, right? Bond formation is exothermic when you have to make a bond between the two atoms, right? So the molecule formation, that is an exothermic process and energy will be given out, right G? So you have to remember it. Greater the bond energy, the greater will be the bond strength, right? Means if I say the amount of energy which is given out by the formation of the hydrogen molecule is huge in amount, it means the bond between hydrogen and hydrogen atoms, that is very, very strong, right? If you consider iodine atoms are too bulky, too large, so when they are joined together in the form of I2, their breakage will release small amount of energy. Their formation will also require the small amount of energy, right? So this you will say the bond energy that is given out is smaller, the bond will be weak, or vice versa. Now here the proper definition of bond energy along with the examples of bond energies are being mentioned along with the units in it, right? So the amount of energy released when a bond is formed or absorbed when it is broken, that is termed as bond energy. I hope you are understanding it well now. That for example, if in it we have H2 molecule to form, 436 will be given out, and if we have to break H2, same amount of energy will be required, right? Same is here for Cl2, which needs 242 kilojoules per mole of energy to break the bond between two chlorine atoms, and if the molecule will be formed, so the same amount of energy will be given out, that is 242 kilojoules per mole. Kilojoules per mole is the amount of energy which is required to make or to break Avogadro's number of bonds within a molecule, that is 1 mole of the substance, right? H2 is 1 mole of hydrogen molecule, Cl2 1 mole of Cl2 molecule. So this is the requirement for the mole of the substance. It is kilojoules per mole. Now these two energies are given by the the homotype of the molecules in which two atoms are similar, but the energy for HCl you can see it is given, that is 431 kilojoules per mole. These are the two dissimilar atoms. Same is here for CH, and then we are given that more than one bond can also be present. Look at this, in oxygen we have oxygen to oxygen double bond. So the energy requirement for this one when you have to break oxygen molecule, that is 498, and if you have to make, the same amount of energy will be given out, right? Now come to the next one. Here it is given again the relation between that of the bond energy and these the units or whatever we have done earlier in these previous slide. It is just a review, right? Now, bond energy or bond enthalpy, the amount of energy required to break all bonds of the particular type in 1 mole of substance, that is termed as bond energy. It is referred as the bond enthalpy. Now, enthalpy is the term applied when we are taking out the reactions at the constant pressure and at the temperature, that is 25 degrees centigrades must. It is the standard one parameter, right? Now, the energies, they are expressed in kilojoules per mole, as I told you earlier. Here it's worth mentioning that a sigma bond, yes, if you remember, S to S overlap, or you can say between two hydrogen atom there is formation of sigma bond. But if we say oxygen to oxygen, there is present one sigma and one pi bond. If you look at the energy in the previous one slide, you will find that hydrogen molecule requires 436 kilojoules per mole for breakage of this one bond. It is a sigma bond. It is much more stronger bond. While the energy requirement for oxygen, O double bond O, that is a little bit less than that for the required for the O2. Right, here it is given, it is 495. So there is much little difference. 436 for just one breakage of hydrogen to hydrogen bond and 495 for the breakage of two bonds. Right, so we can say that sigma bonds are stronger bonds than that of the pi bonds. Right, and what is the reason behind it? That pi bonds, they are formed by the above and below overlaps, what you say, the lateral, or you can say the sideways overlap of the p orbital. So the electron density is lying above and below the central plane. Right, now here these two bonds, they are also termed as a multiple bond, or multiple bond can be termed as that of the carbon to carbon double bond, carbon to carbon triple bond, nitrogen to nitrogen triple bond. So these are called multiple bonds, means sigma plus pi. Both type of the bonds are present in a molecule, as I told you here. Now, also, if there are multiple bonds in a molecule, the heat required to break the bonds will be different for each bond present in between the bonded atoms. Definitely. First, there will be the breakage of a pi bond that needs a less amount of energy, and then there will be the breakage of the sigma bond between the two bonded atoms. So the energy requirement will be higher, as sigma bonds are stronger bonds than that of the pi bonds. You can write it as a what you say, difference between sigma and pi bond. Now, next, to find out what the relationship between bond energy and that of the ionic character. Before I go to this topic, you should know what is meant by ionic character. Look at this molecule. Here it is, hydrogen and Cl, as well as hydrogen to hydrogen. Both atoms are same in this case. They are joined together by a sigma bond. No difference in their sizes, no difference in their electronegative value, whatever. All the parameters are same, right? So no any differentiation of charge is present in it. None of them will acquire partial negative. None of them will acquire partial positive charge, right? It is a non-polar molecule. But what about H2? It is a polar molecule. Two dissimilar atoms are joined together, chlorine having large size as compared to hydrogen, and it is more electronegative than that of hydrogen. So what happens? Chlorine is dominating in this molecule. As it is more electronegative, so electron pair between two will be more towards chlorine. It will be attracted more as compared to that of hydrogen. So what will happen? It acquires a partial negative charge, while the other will acquire a partial positive charge. What happened in it? There are present now two poles in this molecule, means there is created polarity. Polarity means distribution of charge has been separated. One of them is partially negative region, rich in electrons, and the other one is deficient in electrons. That means you have to give it a partial positive charge. Right? Now, this one will affect the bond formed between these two. The energy required to make this bond, to break this bond, or the energy given out during the formation of this bond, that will be affected by all these parameters. Right? Now, here the strength of a bond is dependent upon the following factors: electronegativity, size of bonded atoms, bond length, and bond order. Bond order means number of bonds, as I told you. Right? Now come to the next one. Here it is. The factors which are mentioned there, they are now explained here. Look at this. This is the first one diagram. You can see this one. This atom is attracting the pair of electrons more towards itself, right? So it is dominating. It has greater electronegative value. Greater electronegative value means it will attract the electron pair towards itself more, so that what will happen to the other? It will become a little bit deficient, right? Greater is the difference of electronegativity between the two bonded atoms. If I say it is hydrogen and it is chlorine, chlorine is having electronegativity 3 and hydrogen is having 2.1. If I make a difference between these two, there will be 0.9 or 0.8 in a difference of the electronegativity, 3 minus 2.2, right? 0.8 will be the difference of electronegativity. But if I consider hydrogen and fluorine, what do you think about hydrogen and fluorine? Hydrogen have same, but fluorine is having electronegativity 4. Find out the difference between these two now. Fluorine to hydrogen. Fluorine is having 4. 4 minus 2.2 of hydrogen. What will you get? You will get the difference of 1.8. Is it? And if it hydrogen, in some books it mentioned 2.1, so it will be 1.9. There is a huge difference between the electronegativity of both of these atoms. What will happen? More electron pair will be attracted towards fluorine due to its electronegativity. So what will happen? Bond length will become small. The bond between these two will be much more strong, right? And whenever you have to break it, it will require lot of amount of energy, as there is a great difference between that of electronegativity. Similarly, compare that of these two. Here it is hydrogen iodide and it is hydrogen fluoride. Look at the size of the iodine and fluorine. Also consider their electronegative values, right? Here the size of fluorine is much more smaller as compared to iodine. You can see. Look at the bond length between these two. It is a larger one than HF, right? Electronegativity of iodine is quite less. It is only 2.8 or 2.5 actually. When you differentiate between hydrogen and iodine, it comes out 2.5 minus 2.2 will be equal to only 0.3 is the difference. So the bond will not be as so strong as it is for hydrogen fluoride, right? So this is how we say that electronegativity will affect. So we will say that hydrogen fluoride bond is more ionic as compared to that of hydrogen iodide molecule formation, right? More ionic means more will be the electron pair attracted towards the electronegative atom. Okay, now this is how electronegativity affects the bond energy. Larger is the electronegativity difference between the two bonded atoms, greater will be the ionic character, and greater will be the amount of energy required, or you can say the bond energy will be high. And then less is the difference of energy between electronegativity between the two bonded atoms, then what will you say? Bond will be weak, right? And ionic character will be less, as pair of electron will not be dominantly attracted by the other atom. Okay, now this is how the bond energy and electronegativity as well as the size they correlate. Okay, now come to the next one. Look at this. Fluorine is having the size smallest one, F12, Size is on increase when we move down there in these halogens, right? Here it is 143, 199. It is the size which is on increase down the group. 228 and then 266. Righty? Now here the energy requirement for this bond formation between chlorine to fluorine will be the highest one. As the size is smaller, the maximum will be the overlap, and it is the least one when we consider iodine molecule, as the length is too large due to the larger one size of the iodine atoms, right? So this is what we say, how the bond energy is affected by the size of the bonded atoms. Now come to the next one. Here you can see how the bond length and bond energy or bond strength are related to each other. Similar is the bond order, right? First of all, bond length. Look at this. Formation of hydrogen halides, formation of HF, HCl, HBr and HI. You know very well now that size of fluorine is smallest one. As we move down, so the size of iodine is the largest one. So smallest will be the bond length, as it is mentioned with the yellow color between HF and then all the other halogen halides. All of the other halogen acids. Okay, now here the hydrogen iodide having the largest one bond length, as it is mentioned here, right, while the smallest one in HF. So the bond energy of these, you can see it is 136 kilojoules per mole for HF, while it is only 71 for hydrogen iodide. So you can say the smaller is the bond length, greater is the amount of energy. Larger is the bond length, smaller is the bond energy. So it is easy to break. Similarly, now comes to that of the bond order. Here it is given in the next diagram. Bond order means how many bonds are present between the two bonded atoms. Here you can see in between carbon to oxygen there is present only one bond. There can be two bonds present between carbon and oxygen. Similarly, find out what the length given over there, and what about the energy, what is their relation. When carbon oxygen one bond is present, the length of the bond is 143 picometers. Picometer is the unit of length. The energy which is present in this bond, it is 358 only kilojoules per mole. But if we consider C double bond O, two bonds are present. Now the bond length reduced due to two bonds in it, one sigma and one pi. The energy requirement increased. Bond formation or bond breakage will require 745 kilojoules per mole of energy. And same is here. You can see when carbon to oxygen triple bond is formed, three bonds are there. Bond order is 3, right? So length further decreased. The bond energy increased. It is 1070. So as the multiple bonds will be there, or the number of bonds between the two bonded species will increase, similarly the bond length will decrease and the bond energy will also be changed, right? Now come to the next one. The other examples are also given between carbon to carbon or nitrogen to nitrogens. You can learn it well, get the difference and find out what is the relation between bond order and that of the energy of the bond. Come to the next one. Here it is given. What is the relation between that of the bond energy and polarity, or the strength of bonds and its ionic character? This is just a repetition as I told you earlier. In case of hydrogen halides, you have done for HCl, HF, HBr. All these were the polar molecules, right? There is a difference of charge. There is a difference of electronegativity. They have the appearance of partial positive and negative charges upon them. So the HF bond is considered the strongest one bond, and bond between hydrogen iodide, it is the least strong bond between the hydrogen halides. Although there is also present the difference of charges. polarity. Both of these are polar molecules, right? But the polarity between HF is higher as compared to between hydrogen iodide, so that the bond energy will also be affected. As the fluorine is having, now put up all the parameters we have done earlier. Fluorine is having highest electronegativity, smallest size in halogens, then it is different than that of the other atom. It is more electronegative, as I told you earlier, right? One bond is present over there in between them, that is a sigma bond, and you know very well that sigma bond is the strongest one bond than that of the pi bond, right? So here it is given, these bonds are the polar bonds, but the difference of energy is dependent upon the size, electronegativity, bond order, everything, all are being included, right? Here it is given, HCl bond requires the amount of energy, its bond energy is 436 kilojoules per mole for the, and it is the theoretical one form. Yes, one thing more very important, that if we consider them theoretically, that theoretical means you have taken out the energy by the breakage of the hydrogen to hydrogen, you place there for the hydrogen chloride, and from Cl to Cl you have taken out for one chlorine atom, you have joined them together with that of the theoretical one amount of energy by adding or by sum of the hydrogen and chlorine atoms molecule and energy which are taken out from H2 and Cl2. But if we go for experimental value, there will be energy difference. This 436 kilojoules per mole energy is experimental value. It is quite higher than it was being calculated theoretically. That is only 338.93 kilojoules per mole. Remember it. Whenever there is a polar molecule, there will be a difference in its experimental and calculated value, right? Theoretical value we only take out theoretically by just calculations, but the experiment value is the exact value which is taken out for that particular bond by the particular methods, right? So here the more is the polarity in the molecule, greater will be the ionic character, and stable or the more strong will be the bond, or you can say the great amount of energy is required to break it. Now come to the next one. Here once again the bond length, you know very well bond length. What is bond length? Here two types of bondings are there. We say this is a covalent bonding. What say? Covalent bonding. Hydrogen to hydrogen start from one nucleus up to the this one. This is the bond length of one atom. Half of the distance between the length of the two nuclei joining line. That is termed as the bond length, right? The distance between the nuclei of the atoms which are joined by a covalent bond, that is termed as a bond length, and it is a covalent one radius which is called, right? Covalent radius means when the atoms they are joined by means of the covalent bonds. How to measure it? It is given, it is the unit for it 1 picometers, that is equal to 1 10 to 12 minus 12 meters, or 1 angstrom, that is equal to 1 10 to minus 10 meters. So both of these units can be used as you have done earlier in the previous one chapter as well, right? So here this one, what the bond length, it says that the atoms in the molecule they are not stationary, means not fixed, they are moving or the vibrating. So the bond length, what to say, that is not a fixed one quantity, minor changes or anomalies will appear in them. So the average bond lengths are being taken out as the atom itself is very small. So how to find out its bond length, right? So it is taken out from the bonded one, already bonded one atoms to get their bond length. That is the distance between the two bonded nuclei. That will give you the bond length, and it will tell you the bond strength, right? Larger is the bond length, weaker is the bond. Smaller is the bond length, stronger is the bond, right? Now here table is given. You can find the relation between that of the length and the energy of the bonds. These are the having different bond order. You will find their single bonded, double bonded, or triple bonded, or the multiple bonded one atoms. or the with the difference of the electronegativity between them, polar bonds or non-polar, all types are being given, so you can get the clear difference, or the what you say, the clear one understanding of all the parameters we have done earlier in the previous slides. I hope you will understand it well. Go through this table, you will get the clear understanding of the topic. Okay, now Allah Hafiz.